Okay, I got another problem here. This one, again, we're going to look for the intervals of concavity. So we're going to need a derivative. And even before we do that, we're going to notice a couple other things. There, you can see from here that we have vertical asymptotes at plus or minus 3. So we're going to keep those in mind when we check for our concavity, because a graph may change its concavity at a vertical asymptote. Even though there's no point there, it might happen. So we got to keep that in mind. So first of all, let's get the derivative. Let's see, we're going to have a 2x with an x squared minus 9 minus a 2x times an x squared plus 4. That makes x squared minus 9 squared underneath here. Okay, so looks like we have, I mean, it's not that much to just expand here. Well, but we could factor a 2x, but same amount of work either way. We have a 2x to the third minus 18x minus 2x to the third minus 8x, and then x squared minus 9 squared. Okay, so that gives us a negative, what is that, 26x over the x squared minus 9 quantity squared. Okay, so 2x minus 2x, double checking all the arithmetic here, 2x cubed. Okay, so now we need a second derivative, f double prime. We'll have a minus 26 times the denominator, so that's the derivative of the numerator, then minus derivative of the denominator times the numerator. Let me try to get a little bit more in there. X like that, there it is. Over the denominator squared, so it'll be to the fourth power. Okay, let's see if we can reduce this now. We got x squared minus 9 as a common factor. Let's take that out. We also have, looks like a 2. So take that out. That'll give us a minus 13 with an x squared minus 9. And then over here, we're just going to have, let's see, we pulled out 2. So we, in fact, I guess we could have made that a minus. And we'll just make this a 13. And this will become a, let's see, negative 52 x squared. That. Okay, I just noticed in here I have in here, I had a 2 pulled out here, and I noticed as I was working that I could pull out a 13, so I pulled that out from here and over here. So I pulled that out front. And then from this step here, after simplifying, I realized I had 2 negatives up here, so I made the whole thing positive. Okay, now, here's the thing. You'll notice that that numerator is never 0. Okay. So that tells you that the concavity is not going to change at an x value. However, I did say that it could change at the asymptote. So let's set up a table here. And let's look at those asymptotes. We said at plus or minus 3, it could be something happening. So there are no other places where it might change, but it might change at these vertical asymptotes. So here it's undefined. But we need to check to the left and to the right. So quick check here. This is your second derivative. work with this function here. And let's substitute in a, let's try, we got a -4, 0, and 4. Okay, so -4, of course, leaves that numerator positive, and the denominator becomes negative. Okay, so we have a positive over negative, which is negative. Okay, when the numerator, when x is 0, we have a positive in the numerator and a negative, still negative. Okay, um, let's see, -4, 16. I'm sorry, this is positive. That's my mistake there. I just double checked it. It's 16 minus 9 under here, which is a positive. And the numerator is also positive. So now when x is 0, you'll have a negative in the denominator and a positive up top. So that makes negative. And when x is 4, again, you're going to have the same thing we had before. On the left there, you're going to have positives for that quotient. So we do see changes in here. So your intervals of concavity, we can see concave up. Let's see. I've been calling that just C up. And that's from -infinity up to -3. And it'd be unions with 3 to infinity. C down would be the -3 to 3. Okay, so just a very quick sketch without going overboard. Whoops, not that quick. So let's see. So let's see, at -3, let's say this is -3 down here. There's a 3. We have those vertical asymptotes like that. All right. And now here it's hard to tell what's happening. We need to take a little bit of our graph theory from our previous classes and realize we have a horizontal asymptote at x equals 1. So that would come across here. And what we're seeing, of course, when x is 0, let's see what that value is. Our original function, x is 0. We have 4 over 9, negative 4 ninths. So it's about in here, about in here, let's say about right about there. It's coming through like that, concave down, heading down, and then coming up on the left side over here. It's coming down like that. So it's coming down this way and up that way. That's about the size of the sketch. So you can see that concave up over here, concave up over here, C down in here. So that's about it.